Hello math students, this is Math Coach Cerise. Today I would like to coach you on the learning target. I can convert a quadratic function from standard form, which is y equals ax squared plus bx plus c, into vertex form, which is y equals a parenthesis x minus h squared plus k. I'd like you to draw your attention to notice how this is a minus sign here and this is a plus sign here. And then these are also what we use for our horizontal and vertical shifts. And also x equals h will be our axis symmetry, and h comma k is going to end up being our vertex. So there's a lot of good information that we can find when our quadratic function is in vertex form. There's 4 steps to converting the equation from standard form to vertex form. I'm going to go ahead and do this first example for you. So our first step is that we want to move over the constant. So we're going to move the constant to the left-hand side with the y. As I do that, I'm going to add a square to both sides so that I can complete the square. And that's what step 2 is. Step 2 is to complete the square on the right-hand side and add the number to the other side. So to complete the square, I look at what the b is, which was 4, and I note that my a is 1. So since my a is 1, I can right away look at my b. I can take half of my b, which is 2, and then I'm going to square that, and that'll give me 4. And that's how I know what to put in to complete the square and add to both sides. This should all look very familiar to you, as we had done this before in completing the square with equations, and I had posted a video on completing the square as well. Now we have y plus 3 equals, we're going to factor this perfect squared trinomial into x plus 2 squared. We're going to move that 3 to the other side, and now I'm in vertex form. And I can see that h is -2, k is going to be -3. Make a note, see how this is plus, but in the vertex form, we have a minus sign there. So I do have to think how this was minus a -2 in order to find the h. The axis symmetry would be x equals -2, and the vertex would be -2, comma, -3. And I can get my information from it. This next problem, I have it worked out here on a piece of paper for you. We have y equals x squared minus 8x minus 6. Our first step to do was to move the 6 to the left-hand side. Once I moved the 6 to the left-hand side, I looked at my b, which was -8. I took half of the b, and then I took half of the b and squared it. And this is how I got 16, which is what I put into my box. I add my 16 and I get y plus 22 equals, this is a perfect square trinomial. Perfect square trinomials come from binomials squared, which was x minus 4 squared. I bring my positive 22 to the other side, and so now I have it from vertex form, from standard form into vertex form. So this was standard form, and I have converted it into vertex form. With vertex form, my axis of symmetry is x equals 4, since that was minus and that's the form. I use the positive 4. The vertex is going to be 4, comma, -22. My third example is here in the middle of the paper. And here I am going to go through that process again. I'm going to move over the 46, add a box. Over here I'm going to have the x squared minus 14x plus the box. My a is 1, so that makes me happy because I know with an a equal 1, I can just look directly at the b. I can take half of that b and then I can half of that b and square it. So this would be negative 7, square would be 49. So this tells me I'll need to put a 49 into both sides, into their boxes. This will give me y plus 95 equals x minus 7 squared. I'll move that 95 over, and now I have it in vertex form, and the vertex is going to be 7 comma negative 95. Finally, example 4. For example 4, I'm going to bring the 7 over to the other side. I'm going to put my boxes so I can complete the square. I see that the b is negative 6. Half of that squared is 9. So there's 9 on both sides. This will give me y plus 2 equals x minus 3 squared. I can bring that 2 to the other side. And now I can see that my vertex will be 3, negative 2. 1, 2, 3, negative 2. That'll be my vertex. I know that my axis symmetry goes right through the vertex, and that would be the line x equals 3. I can see that the a is 1 in standard form and in the vertex form. We have the vertex. We have the axis symmetry. The x-intercept. To get the x-intercept, I'm going to have to set this equal to 0. And it would be nice if this was factorable, but it's not. So I'd have to use the quadratic formula. Using the quadratic formula, I end up with the solution that x will equal 3 plus or minus the square root of 2. So it'd be 3 plus the square root of 2, 0, and 3 minus the square root of 2, 0. If you need more help with using the quadratic formula, I have 2 videos on that, which you can find on my channel. Remember, the y-intercept is 0 comma c, so that would be 0 comma 7. 1, 2, 3, 4, 5, 6, 7. There's the y-intercept, which I'll just call p. With the y-intercept being 1, 2, 3 places from the axis symmetry, 3 in the other direction would give me p prime. And so that would give me another point. My discriminant is b squared minus 4ac, and that would be 36 minus 4 times 1 times 7, which would be 8. So this justifies that I will have 2 irrational roots. Finally, they're asking for some other points. If I take x equals 1, and I plug that in for x, I'll end up getting 1 minus 6 is negative 5, so that gives me 2. So 1, 2, that could be considered a q. That's 2 places to the left. So if I go 2 places to the right, then I'll go ahead and get a reflective point, and now I can make my graph. And there you have it, students. This was a complete worksheet on I can convert a quadratic function from standard form into vertex form. We have the steps. We have 1, 2, 3, 4 examples, also with an example of finding the vertex, reflective points, and the axis symmetry, and the y-intercept. Those x-intercepts, those would be right here. And you can see how they're not right on any corners. And so this would be the 3 plus the square root of 2. And this would be the 3 minus the square root of 2. So we actually got 2, 4, 6, 7 points in our parabola. I hope you found this helpful. And if you have questions, please bring them to class. We will practice this in class. And this is a great start to getting better at converting a quadratic function from standard form into a vertex form. Have a great day, and thanks for listening and all your efforts.